Now let's look at the Lftp client. It features a sophisticated, feature-rich FTP client. And by feature-rich we mean it provides connectivity to the following types of servers: FTP, HTTP, as well as HTTPS, SFTP, which is basically SSH, using the current version, version 2, as well as others. So with this one client, you can connect to a wide variety of servers. It runs in interactive and non-interactive modes, which means you can script the process or use it like a basic FTP client. So this means it supports scripting, and as a result, I personally weave Lftp into as many of my connectivity related work as possible. It works for that purpose and it does it pretty well, but it is also a basic FTP client at its core. Now let's determine whether or not it's installed locally. Since we have an FTP server running on Linux CBT Serve 4, which is the VMware instance, let's kill, by the way, this download is still running, we'll kill it. And it's waiting to receive the entire file. And we'll just Control-Shift-W to kill the whole session and find a spare window on our local system. We'll RPM query all grep Lftp. You'll see that it's installed. It is by default, which means we'll just execute, once it comes back in RPM query list, Lftp. And here are the included items. The main item being the Lftp binary itself, located in user bin. There is a global config file, or a system-wide config file, which is read by Lftp in etc, but it also reads per user config files. So we should note, reads system-wide etc lftp.conf and per user config files. The per user config files are in the user's home directory and are usually named lftp-rc. So it'll read directives supported by Lftp, whether you want to set passive versus active, perhaps to force SSL versus not to. All of those items can be read from either config file, and you can determine the settable items by navigating into Lftp's interactive interface and just type set-a, for example, and you'll see all of the items that may be set in your per user or system-wide config file. So again, Lftp with no options propels you into interactive mode, and you can use that mode to connect to servers, discover variables, so on and so forth. So usage. Lftp enters interactive mode. When in that mode, execute, for example, set-a reveals all variables, including the ones that are set. Ones that are not set have blank items returned, such as set SSL CRL file. Certificate revocation list file is currently unset. So if you see double quotes or no option set, it means the item isn't set. Otherwise, you see default and any items that have been downloaded from the system-wide etc lftp conf file. In fact, a less of etc lftp.conf reveals the defaults. dir can be typed when in Lftp to mean ls. Less references more. Z less, Z more. The nature of the prompt and other items are set. Maximum redirections. FTP passive mode off is disabled, which means passive is used, etc. These are defaults that are set globally. A user may optionally set an Lftp file in LFTP RC or in the LFTP hidden directory, which contains the command history and so on. It's another thing we should note, and that is that LFTP behaves like the bash shell. It supports a command history, for example. It also allows you to run background jobs, so permits execution of background jobs, which means you can set up one job to download a file, send it to the background, and open another FTP session. So again, general use is set-a or LFTP followed by the username, let's say LinuxCBT, optionally password indicated by colon, at the IP address or host name of the target system. Let's connect to our VMware instance as the user LinuxCBT. This will prompt us for authentication once we've pasted it. And providing we've authenticated properly, we'll be able to enumerate the contents of the directory. When you connect using LFTP, by the way, you are not immediately connected to the server unless you execute a command against the server, such as ls. This creates the connection. All of the LFTP commands, or all of the FTP commands, are supported by LFTP, such as pwd or cd to change a directory to some other directory, like the root, for which we're currently jailed or change rooted to a jail so we cannot escape. Get, mget, all those items work, but don't memorize them. Just type help and you'll see the standard set of FTP commands, including an extended set supported by LFTP and LFTP alone, which leads us to another feature. That is, it supports mirroring forward and reverse of content using FTP via the mirror option that we see here. But again, everything you will find with FTP and then some is supported by LFTP. So now that we're connected to get an item, we can get it using mget. But we can also cat the contents of a remote item using zcat. But because we've limited the transfer rate, we'll simply download the file so that you see it using mget and the name of the file. We should also note as a bash feature, and it's all coming to mind as we talk about it, is that it supports tab completion. So for example, in this recent example, when I quickly got the name of the file, I typed in the most unique characters that came to mind, li, then tabbed it out, and I did the rest. Now in getting it, notice the rate at which we're receiving data. It's really slow. Each command supports additional options. Just execute help and the option mget, and you'll see those various options. You can continue where you left off, for example. So it's another feature. Supports FTP, retransmit, reconnect from where you left off, so that you don't have to re-download an item from the beginning. So we broke purposely the get of linuxcbt.text, and ls l of linuxcbt.text will reveal that it is currently 131,072 bytes. This is a 6.6 megabyte file. So now at mget-c, the name of the file, will continue where we left off, downloading the file. Now if it takes too long to connect to the remote FTP server, it means you need to break your connection and reconnect. Sometimes the connection to a remote server gets clobbered and you need to reinitiate it, as we're currently doing. The command history is here, so just arrow key up and you'll find the recently executed command. See it picked up at 2%. If we were to kill it and start over at 3% or 4%, it would pick up there as well. Let's go ahead and kill this. Notice the transfer rate is returned 1.6K per second. We limited it to about a K per second, which is where this is heading to. And it gives us a long ETA of over an hour, almost 2 hours in this case, to download such a small file. Let's kill it, exit, and on the remote server modify the config file, etc vsftpd vsftpd.conf. Let's search for where we have 1000 bytes per second, and let's add a 0 to make it a little bit faster. This will be 10,000 bytes per second. And then you'll see that the file, once we re-execute the service restart, will come down much quicker once we've FTP'd in using Lftp. Now we're on, and we'll mget-c, and you'll see that the rate will pick up. So now we're at 3% where we left off, and we'll get a transfer rate that's now much, much faster. It should be roughly 10 times faster, as it hovers around 10K per second, and average that much. Now let's kill it, bump it up again. And let's navigate back to the configuration, and bump it up from 10,000 to 100,000. And now the file will come down much quicker after we've restarted the service. Let's try to pull it again. We'll quit, relaunch the session, ls, and if we lsl the same file name using tab completion, we'll see where we are with the file, 393.216, roughly 5% of it. So let's mget-c again. The command history is maintained on a per user basis, so use your up and down arrows to navigate through previously executed commands. And this will pick up where we left off at 6%, and now it's definitely cycling through much faster at about 100K per second. And it will continue to download the entire file. So you can continue where you left off with uploads and downloads using Lftp. So third usage would be to mget-c, which continues downloads. And an optional usage would be mput-c, which continues uploads. We'll take one of the larger files that we have locally and attempt to upload it momentarily. This should be almost done. And from a separate shell, it's Control-Shift-T. Let's see what we have available in terms of text files and in terms of size, and we see 6.6 megs for the 1 million file. This would be good to attempt to upload. Let's take another version of it, the tar instance, and we will attempt to enumerate the contents and put. We'll break the put, so now it's at about 10% roughly. We'll kill it, reconnect, and then continue to put it using mput-c. They'll pick up 13%, kill it again, so on and so forth. Again, usually when you kill sessions, you lose your Lftp instance. You have to reconnect altogether. You have to quit and reconnect. You may also connect using the password at the shell by indicating the username followed by the password. This will allow you to connect without having to specify the password, but you run the risk of the password showing up in the user's bash history file, so beware of that. It'll show up, the fact that we executed it, and in this case we don't see it, so that tells us that it isn't there for this particular instance. But nonetheless, if we arrow key up, there it is, indicating that it is somewhere in the command history, and as a result we need to be careful. Now if you Lftp in general, it propels you into interactive mode. Lftp-help returns various options, including alternative ways of indicating the credentials using the -u option. So instead of colon, which is the standard URL option, we could do as follows: -u, username, comma, password, no @ symbol, space, IP address of the site. The site can be FTP, HTTP, SFTP, you name it. Now it connects us. Let's try it with SFTP. SFTP : / would connect us using SFTP. And now we have an SFTP instance, and we see the hidden files there. So another usage would be as follows: LFTP user password followed by an SFTP URL. And this connects to SFTP server and will allow you to put and get files just like you're able to do with FTP. So for example, let's mget or mput C, since we broke it. And the same history that's used for normal FTP connections can also be used with SFTP, so you can continue where you left off, and there you see it picked up at 23% and uploaded it. But notice the difference in the transfer rate, because now we've connected to the SFTP server running under the auspices of SSH, which doesn't have a rate limiting mechanism in place. So it transfers as fast as the wire will allow it to. And as a consequence, the file is now there, and if we lsltr, we'll see that it's the full size as it's represented locally. And again, there are myriad commands. You can zcat, for example, a compressed file on a remote system to examine the contents of it. So on the remote system, let's sun as Linux CBT. We'll sequence 1000, or let's sequence 10.tex. Now from the LFTP instance, when we LSL, we'll see 10.tex, and it doesn't show, it hasn't refreshed it. Let's try to examine the contents of it using ls, and it doesn't see it, so we'll have to reconnect, and now it sees it. So again, if the file were compressed, we'd be able to zcat it, but it's not, so we can cat it. Just cat 10.tex, and there you see 10.tex. It actually transfers the bytes but dumps the standard out, the contents of the file, which is why, again, LFTP is more like the bash shell than many other FTP clients. It allows you to do these different things. Also mentioned, you can display jobs. If there are jobs running, there are currently no jobs. You can background a job that's going very slowly. Let's say the upload of a large file. Control-Z to put in the background and use jobs with the optional verbose command to see the job. Help jobs, or help any command, returns the options that may be indicated with, or the general usage of the command that you're querying or inquiring about. And as far as mirroring is concerned, let's say on the remote system, we're going to use FTP of course, but on the remote system we had a directory structure that we'd like to mirror. So we'll make directory mirror. Then we'll move 1,000,000 linuxcbt.tex and 10.tex into mirror. And now supposing we wanted to mirror this entire directory locally. Well, the default behavior of the mirror feature is to download, synchronizing the local system with the remote. So mirror verbose mirrors a remote, and since we're going to focus on the directory, mirrors a remote directory named mirror to the local system. And you may optionally reverse mirror. Let's take a look at that. So now we're going to connect using plain old FTP. If you don't indicate the protocol, FTP is assumed. Once there, we see that there's a mirror directory. If we execute help mirror and tab it out, you'll see how to use mirror. Mirror, you can continue optionally, delete. You can download only newer items. You can turn off recursion. By default, the mirroring is recursive. It will go through or search through directory trees in attempts to mirror all of the included directories and files. Whether or not to set file permissions, whether or not to include or exclude items based on regular expression patterns. But basically, you'd use the mirror as follows. Mirror verbose, followed by the name of the directory. This will mirror the mirror directory to our local system at whatever transfer rate is in place, and from a separate window we can confirm locally what's going on. lsltr, we see the mirror directory has been created locally. If we navigate into the directory, we'll see that the file is growing, 1,000,000.tex.tar. Turn on -h, it's now 2.2 megs, 2.4, so it's being mirrored all together from the remote system. We can reverse mirror. What we'll do is, once we've downloaded the items, we'll reverse mirror to the other system. So mirrors a remote directory to the local system, whereas if we were to mirror with the RV option, the mirror directory, this is a reverse mirror, which means it puts items to a remote server. So if you've got a directory structure, let's say a web application directory structure that must be mirrored from your local system. So supposing you do your web modifications locally but need to publish the differences to a remote system, you could then use mirror with the R option, the uppercase R option, to reverse mirror. And that's a great way to take advantage of that feature set. We could also launch another session. We could background this job if we'd like. Control-Z does a trick. It places the job into the background. Jobs verbose returns information. Notice we're now doing jobs-V. And we see the percentage of the transfer as it happens. But it doesn't actually kill the job. So perhaps as a feature we should list that it supports, and we've already indicated that it permits execution of background jobs, and that's using Control-Z to background and use jobs-V to interact with the jobs. We see it's at 92%, and it will continue to transfer. We can change who we are, credentials, by indicating user, followed by the credentials. We may bookmark URLs, which get stored in the configuration file in our LFTP hidden directory beneath our home directory. So that's another neat feature, the ability to bookmark sites. We'll list that as another feature as well. Supports bookmarks of sites. Again, another neat feature which makes this program such a good program. And as we can see, the job is over. Now on the remote system, we can either through LFTP or in a shell remotely remove the contents of the directory. So let's remove RF mirror. It's now gone from the remote system. And then locally, if we attempt to look at the directory, it appears as if it's still there. However, if we disconnect and reconnect, you'll see that it's not there. But locally, we have the mirror directory. So if we help mirror, you'll see that with the upper option for R, it's a reverse mirror, or the long option -- reverse. So mirror RV, the mirror subdirectory, will post the mirror subdirectory to the remote system. And once we navigate to a shell, we'll see that it has been recreated. And if we navigate into the mirror directory, we'll see the file being grown. And in the sake of being able to control the LFTP interface, we'll Control-Z, but have jobs handy to get a sense for the progress of our upload. This tells us that it's at 37% for this particular file. So we can forward and reverse mirror. Again, there are just so many options that LFTP supports. It's an invaluable tool as a result. You can remove directory structures, make directories, kill jobs. So for example, jobs-V lists jobs that are currently running, and you can kill these jobs. This is job 0. If you launch another job, such as putting another item, let's find something local to put. And we'll LSLH or LSL, so we see it long format. Let's put this test1million file. This launches another job, which we can Control-Z again. And now it's job number 1. So now we've got 2 jobs, 0 and 1. We can kill the job if we'd like, using the kill command, followed by the number of the job will allow us to easily kill that job. Not a big deal. And the other options, you can navigate to the shell if you'd like. All our jobs are running. We have 2 jobs. Again, jobs-V tells us. If you indicate bash, exclamation bash, we're now at a bash shell. LFTP is still running. We can return to LFTP by exiting, and this takes us back to the shell. The shell resembles the bash shell, but it has a prefix of LFTP so that you can differentiate between a true bash shell and the LFTP shell. You can execute any command from the shell, such as !PSEF, and it runs it within the LFTP instance. So as additional features, supports escape to shell using exclamation and command. Example given, !bash launches a bash shell. And it also supports the execution of bash programs in general using the same exclamation command. Another example given, !PSEF, doesn't dump you to shell, it simply runs a program and returns the output from the program to standard out within LFTP. And we did also mention that LFTP supports scripting. If you define a script with any supported LFTP command from the shell, you can execute that command. Let's take a look at our jobs list. We've still got jobs going, so let's go to bash, LFTP help. If you launch it with the -F option, just like with awk and sed, followed by the name of a file, it'll do exactly as you say. So for example, nano LFTP test script. Anything you can type in from within LFTP will be executed. So this opens a new instance, and on the road system we can launch an instance of LFTP. Help open. Always type help followed by the command, you'll see the usage. So open U and site. So open U, user being Linux CDT, password being ABC123, and the site being 192.168.75.199, followed by ls-l, followed by quit, is a script. It opens a connection, lists the contents of the remote server, and quits. Now you execute LFTP-F, followed by the script name, and it does exactly that. It connects to the server, lists the contents of the server, and quits. If you indicate incorrect credentials, for example, it fails. So let's make ABC123.123.4, which is an incorrect password, and you'll see that it fails. Sending commands, it's trying to send the commands, it comes back with a 530 login incorrect. But if the credentials are correct, then anything you indicate after the authentication step will work. But of course, the only caveat to using scripts is that you must include credential information which may or may not suit your situation. And again, the command history is maintained in the hidden LFTP directory. You've got two files, rl_history, which has a long list of the various commands that we've run, and cwd_history, which has a list of the items that we've connected to and the various directories we've connected to on those items. They're maintained beneath the user's home directory in the hidden LFTP directory. You may additionally maintain an LFTP RC file. For example, let's say when you enter LFTP, you want to set a value such as, let's find something sensible to set. Set X for verify no. We'll set this to yes from our file. So nano LFTP RC, and just place this item, set X for verify yes, and then it's saved as .lftp_rc. Now when we launch LFTP and type set-a, set X for verify is set to yes because the user's per user RC file, that is, has been read. So you can override global settings. But let's just get rid of the LFTP-RC. That's just a simple setting. I often use it to determine whether or not a passive versus active, or SSL versus non-SSL. In the case of SSL, sometimes you need to force SSL connectivity to certain providers' sites in order to connect. And that's a great usage of the hidden LFTP-RC file. Now again, we were doing all of this in a bash shell that we escaped from LFTP. If we exit, we're back within LFTP, where its command history takes over, and both jobs have finished. So now we can exit the shell, and we're done with LFTP for now. Again, just like with the other tools, we use them sporadically throughout our studies because they're important to help us move files around. But just know that LFTP supports many, many features, many options. It provides many features and supports many options. It's an invaluable tool used to connect primarily to FTP servers, but can be used to connect to HTTP servers. Again, we showed you that early on by connecting to the RPM repository by simply taking the URL. You take a URL, and it's not going to allow you to write to the server. The server will prevent you from doing that. But if you LFTP followed by an HTTP URL, an LS, now you can interact with all the files there. Some features won't be supported when using standard Apache configuration, such as globbing, but nonetheless, you can interact with the server, and in particular, you can pull files that you need to your local system. And if puts are supported with a different protocol, such as SFTP or FTP, then it'll allow you to do that as well. So that's a little bit about using this really powerful FTP client. We'll move on to some other interesting items.